Hello friends, welcome to the channel Mind Your Math. I am presenting again a question from integral calculus. This was asked in KVPY exam in India. Pause this video, try this question and see whether you are able to solve this. So the question here is 0 to pi by 2 sin x raised to root 2 plus 1 dx upon, this is integral 0 to pi by 2 sin x raised to root 2 minus 1 dx. You have to get the ratio of these two integral, and what is the answer? Try this question. Okay, now let's discuss this. So the question here is, we have to find the ratio of these two integrals. The difference between these two integrals is the only thing is sin x raised to root 2 plus 1, and here this is sin x raised to root 2 minus 1. Now before solving this question, I'll just quickly go through one concept which we'll be using here, that is the integration by parts here. So what is an integration by parts method? Let's say you have integral of product of two function u into v dx, then we can integrate this by one function, let's say this is vx, and to integral of the second function, that is ux dx, minus the derivative of this first function, that is the function which we have not done anything in the first step. Okay, so derivative of this vx into the integral, that is this part, integral ux dx, and then is integrated again. So this is integration by parts. So we will be using this concept for solving this question. Okay, now let's say we have this integral, this we are saying this for numerator integral is I1 and the denominator is integral is I2. Now to get the ratio of these two integral, what we will try to do is, we will try to get one integral in terms of other. Okay, that is, we'll try to get the integral I1 in terms of other or vice versa. So we can start with any of the integral. Let's say if I take I1, which is integral 0 to pi by 2 sin x raised to root 2 plus 1 dx. This is the integral numerator, right? I1. Now if I start manipulating this, first thing you can see, this is 0 to pi by 2 sin x raised to root 2 into sin x dx. Now to integrate this, you can see, if I consider this as our one function and this is another function, so here we are saying this is one function is u, other function is v. So what we will do is, we will differentiate this and we will integrate this, because we know the integral of sin x, right? So what will be the integral value here? So this is sin x, integral sin x, that is, we are applying by parts, that is sin x raised to root 2. This is our, let me write it, this is our v function and this is our u function. Okay, so this is sin x raised to root 2 into integral of sin x. What is the integral of sin x? This is minus cos x, and we have the limits 0 to pi by 2 minus the integral is from 0 to pi by 2, and this is sin x, that is derivative of sin x raised to root 2, this is root 2 sin x raised to root 2 minus 1 into cos x, and the integral of this, that is what we are using, is the integral of u dx, right? So this is, what is the integral we have got, this is minus cos x dx. Okay, so just simplifying this, you can see, if I just put pi by 2 here, this term will be 0, and if you put 0 here, this term will be 0. So this part effectively is equal to 0, just substituting the limits. So from this you can say our integral I1, this integral I1 is basically 0 to pi by 2 root 2 sin x raised to root 2 minus 1, and this is minus cos x, so this will become plus and this will become cos square x, and cos square x you can see this is 1 minus sin square x dx. And now further you can see, if I just simplify this, this is root 2 integral 0 to pi by 2 sin x raised to root 2 minus 1 minus root 2 0 to pi by 2, just multiplying this, this is sin x raised to root 2 minus 1 into sin square x, will make it root 2 plus 1 dx. Here also this is dx. And now you can see this integral is our integral I1 only, this integral is I1 only, and this integral is I2, and this integral is I1. So you can see we have I1 is equal to root 2 I2 minus root 2 I1. So from this you can say, arranging the terms, this is root 2 plus 1 I1 is equal to root 2 I2. So what is the final answer? We have to write I1 by I2, which is equal to root 2 by root 2 plus 1. So this is the final answer which is required for us. You can further simplify this if you want to rationalize and write this. Okay. So you can say, if you further want to simplify this, this is I1 by I2, just rationalizing this, this is root 2 minus 1. Okay, so this is 2 minus root 2. So what is the final answer? This is 2 minus root 2. I hope you got the answer and you have understood how we use this integration by parts for finding the ratio of two integrals. Okay. Thank you for watching the video. Please like and subscribe and share the video.